All right, hello folks. I'm here to talk through the answers for Chapter 3 classwork. Before watching this video, you should have done a couple of things. So far, you should have read the Salkind Chapter 3 on measures of dispersion and variability. You should have watched both parts of the Chapter 3 lesson, Part 1 and Part 2, that shows you how to do the analyses for dispersion both by hand as well as in Excel. Remember, the lesson outline can be helpful for taking notes during both of those parts. And then you should have attempted this classwork so far by yourself before just jumping ahead to the answers. If you didn't do so hot or as well as you wanted to on homework 2, make sure that you remember the classwork is always your opportunity to do a practice homework. The classwork always closely models the homework, so try it on your own first before just jumping to my answers here. Okay, so if you've already done that, let's look at the answers and check your work. So the first one is asking you to calculate all appropriate descriptive statistics and then report them in sentence form. So remember, for an interval level variable, there's always 5 things that you need to report. The n, that's how many values there are. The minimum value, what's the lowest one? The maximum value, what's the highest one? Either the mean or the standard deviation, depending on if there are outliers. And then, the mean or the median, depending on if there are outliers. And then the last thing is the standard deviation. So the first big chunk of this is determining if there are outliers, right? That should we be using the mean or the median? And to determine if there's outliers, the first step, and this is review this mean versus median, is the measures of central tendency that we did in Chapter 2, so this part should be review, is to first list all of the values in order, high to low, low to high. Find the middle value. Here there is an even number of values, so there's 2 values in the middle. So we take the average or the mean of those. 78 plus 72 divide by 2 gives us a median then of 75. 75 is the middle value. Then we need to find our first quartile or our 25th percentile, and then our third quartile or our 75th percentile. To find our Q1, then we're looking at all of the values above the median. So from 38 down to 72. There's 4 values, so that means there's 2 middle values, 49 and 64. In that top half are the middle values. Then that's, or really our bottom half, our lower values. So 49 plus 64 divided by 2 gives us a Q1 of 56.5. Then we're doing the same thing in the upper half of values, right? So 78 to 98, there's 4 values, which means there's 2 middle values of that second upper half. And so we do 80 plus 94 divided by 2 gives us a Q3 of 87. So in order to then start the process of identifying if there's outliers, we need to calculate our interquartile range, or our IQR. So we're down here now. The formula for IQR is Q3 minus Q1, where we plug in those values that we just got from here. 87 minus 56.5 gives us an IQR of 30.5. Then we're calculating what are the bounds, what's our lower bounds and our upper bounds beyond which an outlier would exist. So the formula for our lower bound is Q1 minus 1.5 times the IQR. So we're plugging in the values here, Q1 from over here minus 1.5 times our IQR, which we got down here of 30.5. Go through and solve the math on that, and you should get a lower bound value of 10.75. Then the formula for determining our upper bound for outliers is Q3 plus 1.5 times the IQR. Plug in our Q3 from over here, plug in our IQR, solve the math on that, and that gives you an upper bound value of 132.75. So this means that any value that's less than 10.75 would be an outlier, and any value that's greater than 132.75 would be an outlier. Here we see there's nothing less than 10.75 and nothing greater than 132, so we know there's no outliers. If there's no outliers, then we use the mean. So our formula for mean, recall, is x bar, remember that's our mean, is sigma, add up everything, all of the x's, all of the values, and divide by n. So we add up 38 plus 49 plus 64, et cetera, add all of these up for a total of 573, divide by the number of values there are. There's 8 values, right? 1, 2, 3, 4, 5, 6, 7, 8, and gets us then a mean of 71.63. So now we have the mean. The other important thing to calculate for interval level variables is the standard deviation. So here's what we've learned in this chapter. So to do this, you are listing all of the values. Again, the order doesn't matter. For these ones, I just so happened to list them in the order that they were given. But if you just kind of copied down the order that you listed them in order for calculating the median in Q1, Q3, that's fine too. Order doesn't matter for calculating standard deviation. So you list all of the values. That's column 1. Remember then column 2 is the mean. So in column 2 goes our mean. Lucky for us, we've already calculated that above. So we know our mean is 71.63. If it's helpful for you, copy that down all the way. I do a quickie cheat with the arrow all the way down. Third column then is our x minus x bar. That means we're subtracting the mean from each value. So we take 72 minus 71.63 to get 0.37. Here's where the rounding to 2 decimal places becomes so important. For something like calculating standard deviation, when there's so many steps, if you don't round to 2 decimal places, your values are going to look different than mine. So that I can help you identify if you made an error in one step, it's helpful for us to all round to 2 decimal places. That way I can identify a spot that you might have gone wrong and one, help you figure out where you went wrong, but also importantly be able to give partial credit because I can see where the error started. Okay, so in column 3, our x minus x bar, then same thing, 30 minus 71.63 gives us the negative 33.63. 64 minus 71.63, negative 7.63. Do that all the way down here, right? So we have all of the values. Remember then at the end of column 3, here's a helpful opportunity to be able to check your work. Column 3, when you're including the negatives, should come out to close to 0, right? If you're rounding to 2 decimal places and there's some rounding involved, it's probably not going to be exactly 0. Like here, this comes out to 0.04. If you got out to something that was like 4.5, you know, that's a red flag that you had an arithmetic error somewhere. So column 3 should always total to something close to 0. All right. So column 1, list all of the values. Column 2, calculate the mean. Column 3, subtract the mean from each value. Column 4, square all of the values in column 3. So 0.37 times 0.37 equals 0.14. Negative 33.63 times negative 33.63 equals 1130.98. This now in column 4, you're getting rid of all of the negatives from column 3. So do that for all of them. Step 5 then for standard deviation is to add up everything in column 4. So you add up 0.14 plus 1130 plus 58 plus 500, et cetera, et cetera. Add up all of these, and that gives you 3007.9. So if we're going now to our formula for standard deviation, we know that our standard deviation formula is S equals, the standard deviation equals the square root of this value we got down here, the sum of all of our x minus x bar squareds, over n minus 1. So here our n minus 1 is 8 minus 1 is 7, so we should have 7 on the bottom here. 8, remember our n is the number of different values there are. Here we have 8 different values, so n minus 1 is 7. Our n minus 1 goes on the bottom. So we solve the math on that, do the 3007.9 divided by 7 to get 429.7. Take the square root of that. Remember when you're doing the square root in your calculator, if you're using an iPhone for the calculator, if when you have it like this, you're not going to be able to see the square root button in the portrait mode. But if you turn it into landscape mode, then that enables you to see all of these other fun options, including the square root. And remember, this is the square root button, the one with the 2 and the x, the 2 square root with the x under the square root symbol. So do the square root of 429.7. That gets you a final answer for standard deviation of 20.73. And then remember here, we're always using the same format for reporting appropriate descriptive statistics in sentence form. The first sentence has the n, the minimum and the maximum values. Range is optional. If you want to include the range, you can. And then the second sentence has either the mean or the median, depending on if there's outliers, the mean or the median, and the standard deviation together. So our final answer here for number 1 is among the 8 values, 8's our n, the minimum value is 38 and the maximum value is 98. The mean is 71.63 with a standard deviation of 20.73. If we had found in part 1 here that there were outliers, then we would be using the median. So instead here, this would say the median is 75 with a standard deviation of 20.73. But because there's no outliers, we report the mean. Okay, I know that's a lot of steps for number 1, but this is like the crux of understanding descriptive statistics, is being able to get to those final reporting sentences. Okay, let's have some fun in Excel now. So 2 is asking you to use Chapter 3, Dataset 2, and to use Excel to fill in the table. So remember, if you are in our modules, in our Canvas site, you scroll all the way down and all of the data sets are listed here. Make sure that when you go to open it, that when you click on it, you are not just looking at whatever preview, but you're actually clicking here so that we fully download the data set, right? That you want to make sure that you have it actually open in Excel. And sorry, I already have this one open for you, so it's gonna, oops, require me to do one at a time. Okay, so question 2 is first having you fill in all of this information for these math and reading scores, right? So it's asking the n, how many values are there? And then all of the rest of this we can quickly have Excel calculate for you. So I think it's helpful. I usually have to click this enable editing button, right? I think it's helpful to kind of set up a little table for yourself for these ones that you're asking Excel to do, so that you remember where each value is going, and then you can kind of write them into your sheet. So if it's asking you to first calculate the minimum, remember for minimum, this part is now review from Chapter 2 last week. You write equals min, and then tell Excel what is the range of values you want to calculate the minimum score for, that you want it to identify the lowest value. Here we're looking at, for the math scores, from this A2, right, column A, row 2, all the way down to A31, right? So A2, remember colon tells Excel what the range is. So A2 colon A31, close your parentheses, and that gives you a minimum of 56. Can go ahead and do the same exact thing for reading score, right? Minimum, but now we're in column B. So B2 colon B31 gives us a minimum of 24. Go back to the column for math. Now we're doing the max. So remember, always in the formula bar, you're typing in equals first. Max A2 to A32 gives us a max of 99. Same thing for reading score, equals max B2 to B32 gives us, oops, no, not 32, 31. My apologies about that. We don't want to include this 32 in there. Did I include 32? Yeah, I don't want to include, it won't change anything, but to be correct, right? And make sure it's always highlighting the right spot. It probably would be helpful to even have made sure that we have a little separation here, might be helpful. Okay, then, I have this right, B31. Gets a max of 100. All right, so now to calculate the range, you have a couple of options, right? We could say equals, the range is the difference between the min and the max. You could say equals A34 minus A33, or you can just type in the actual values instead of the names of the cells. So here I could do equals 99 minus 56 gives us the range for math scores. Same thing for reading scores, equals equals 100 minus 24 gives us the range for reading scores. Then for mean, remember Excel uses average as how to calculate the mean. So now we're doing equals average, telling it what's the range to look at, A2 to A31. That gives us a mean of 81. Here equals average again. Now we're in column B, B2 to B31 gives us a mean of 76 for reading scores. Then for standard deviation, remember for standard deviation, Excel has a couple of different choices of types of standard deviation beyond the scope of our class to understand what those mean, but you're typing in the STDEV.S is the one that we want to use for our purposes. And then again, the range, A2 to A31, and that gives us a standard deviation. Same thing then for reading score, standard deviation.S. Now we're in column B, B2 to B31, gives us a standard deviation there. So for problem 2, you can just go ahead and copy and paste all of those values in here. And so for some of these, it looks like Excel rounded for us. It doesn't really matter for these purposes of coming from Excel. I'm less demanding. And you see, I don't ask you to round to 2 decimal places or whatever here when it comes from Excel, because the Excel is just giving it to you. I don't need to be able to see where your final answer may have come from or give you partial credit or not. The rounding is less important. So you can copy and paste your answers in here, and then 2B is asking you to write a few sentences reporting the appropriate descriptive statistics. So you can do the math scores first. So you would say among the 30 students, 30 is your N, the minimum score was 56, the maximum was 99, the mean was 81.3 with a standard deviation of 12.357. Then do the same thing for reading scores. Now, 2C is asking, do math or reading scores have greater variability, and support your answer? So remember, a higher standard deviation means greater variability, means that the values are more spread out. So higher standard deviation, greater variability. So here we're comparing the standard deviation for math scores to that for reading scores. The reading scores have a higher standard deviation of 18.7 than the math scores do, right? So that means that reading scores have greater variability. Those scores are more spread out. On average, each value is farther from the mean because the standard deviation is greater. All right, and then last part here on number 3 is using our class survey data set. This first one is asking, is there greater variability in the number of states visited or the number of pets owned? So first we need to calculate the standard deviation for states and then for pets. Oops, and I somehow got this closed out. Let me reopen from our Canvas page our class survey. So remember, we go all the way down in modules, and you want to make sure that you're fully opening the survey, right? Download it into Excel, so we're not doing the Excel ones by hand, especially for standard deviation ones. Okay, so we're looking at, let me refresh my memory, for states and pets. So for pets, this is question 6 on the number of pets people have. We want to calculate the standard deviation for that. So we do the standard deviation.S, tell Excel what is the range of data to be looking at. We're looking here at F2 to F29. That gives us a standard deviation of 5.159. And the other one then is states. So here we're looking at column E. And again, the equals standard deviation dot S, tell Excel what's the range we're looking at, column E2 to E29. And that gives us a standard deviation of the 3.57-ish. So now we have these two standard deviations. Remember, the higher standard deviation means greater variability. So our final answer here is that there's greater variability in the number of pets people own than the number of states they visited because that standard deviation is greater. Okay, B then is asking about the average number of siblings in the class. So average as in what's the measure of central tendency? Should we use the mean or the median? And so for this one, the number of siblings, we have to, let's find our siblings row here. Remember when we're determining in Excel, whether or not there's outliers, which is the first step in determining if we use mean or median, it's helpful to set up this little table for yourself with Q1, Q3, your IQR, then your upper bound and your lower bound, right? So to calculate our Q1, we use the formula, and remember this part is review from chapter 2. So look at that last page of the lesson handout for chapter 2, has all of these step-by-step instructions too. I expect you to automatically remember these fresh from your mind, but to calculate for the Q1, we type equals quartile, give SPSS the range of data we're looking at. So we're in column H here, we're doing H2 to H29, and then tell them what quartile we want. We want the first quartile. So we do the range of data, comma, 1, and then enter. That gives us our first quartile. And then our third quartile is the same thing that we're taking equals quartile, the range of data, H2 to H29, except now we want the third quartile, so we say comma 3. That gives us our Q3. Then our IQR we know is just our Q3 minus Q1. 5 minus 1 is 4. Then to calculate our upper bound, the formula for that is Q3. So here our Q3 is 5 plus 1.5 times our IQR, which is 4. So the formula for the upper bound is always Q3 plus 1.5 times our IQR. That gives us 11 for the upper bound. Then the lower bound, use the formula, always put in your equals first. Q1, here our Q1 is 1 minus 1.5 times our IQR, which is 4. So the formula for the lower bound is always Q1 minus 1.5 times our IQR. That gives us a lower bound of -5. So now we're looking at our data and determining, is there a value that's less than -5? No, that doesn't make sense. Somebody can't have less than 5 negative, in case somebody can't have negative siblings. Or greater than our upper bound, greater than 11. And oops, we see somebody has 12 siblings. So this 12 is an outlier. Since there's an outlier, that means the median is appropriate. So here the median number of siblings is 2.5. Oops, and I have to show you how to calculate the median. So if we want our median to go here, we put the cursor on the cell where we want the answer to go and type in equals median, and for the range is cell H2 to H29. That gives us the median of 2.5, the middle number. So here we would say the median number of siblings is 2.5. I used the median instead of the mean because there are no outliers. And I think, sorry, on my answer sheet, I don't have the full correct question the way I changed it for your class here, but your classwork sheet says what's the upper bound and what's the lower bound for determining if there are outliers. And here we saw that our upper bound is 11, and so that is somebody with outliers. And the person with 12 siblings is an outlier. Okay, and then part C of this one is we're reporting all descriptive statistics for mother's education level. So here to do the appropriate descriptive statistics for mother's education level. First, we're finding that variable that's in row J here. And for a mother's education level is an ordinal level variable, right? It doesn't have numeric categories. They're mutually exclusive categories that we can rank order, but we can't quantify the distance. So we should be using mode for the appropriate measure of central tendency. And so when I say report all appropriate descriptive statistics for a nominal or an ordinal level variable, you're reporting the n and the mode. So to calculate the mode here, we put the cursor on the cell that we want our answer to go, then type into the formula bar at the top, mode, and the range of data we're looking at here, which is J2 all the way down through J29. That gives us a mode of 1. Remember though, 1 is just what the category is coded as. We need to use the mode that's the actual name of that category. So to find that, we click on down in the bottom left here. Instead of having this data tab open, we're looking at the codebook tab. And so we find the variable on mom's education level and see that 1 equals high school or GED. So our modal category is not the number 1. Our modal category is high school or GED. So here we see that we have 28 students, right? That there's, in our data set, we see we go down to row 29, and yet this first row, right, is the names of the variables. So we have 28 students who are responding. Among the 28 students, high school or GED is the modal category for this variable. Okay, and then the last step here is asking you to report all appropriate descriptive statistics for the amount of money spent on a typical night out. So we go to this variable on money spent. We are first reporting the N, which is still 28, right? We report the minimum. We want to calculate the minimum value, the maximum value, and the know that we have to do our standard deviation, and then are we using the mean or the median? So to remember to calculate the minimum value, we're using just min parentheses L2 to L29. That is the minimum somebody said is 0. The maximum is equals max L2 to L29. The maximum is $200. To find the standard deviation, we do equal standard deviation dot S, L2 to L29. And that's the standard deviation is 38.77. Then we also know that we need to figure out, are we using the mean or the median? We need to determine if there are outliers. So you need to go through the steps like we did before of figuring out our Q1, Q3, our IQR, our upper bound and lower bound. And I'll go through this part kind of quickly because we already did this as the example with a number of siblings. But so to calculate our Q1 is quartile, L2 to L29, comma 1. Our Q3 is equals quartile, L2 to L29, comma, oops, I missed the L, L29, comma 3. Our IQR then is our Q3, which is 56.25, minus our Q1 of 50. Our formula for the upper bound is our Q3, 56.25, plus 1.5 times our IQR, which is 6.25. Our formula for the lower bound is equals our Q1 is 50 minus 1.5 times our IQR is 6.25. So this is giving us now our range beyond which outlier would exist. So we're looking now in our data for money and see, is there something that's above 65.62 and is there something that's below 40.625? And yes, right, there's outliers at both ends of the spectrum. And because then there's outliers, we know that we should be using over here the median, not the mean. So to calculate the median, we do equals median, L2 to L29 is the data we're looking at, and get a median of $50. So now here's all of the data we need to give our final answer, right? So among the 28 students, the minimum amount is 0, the maximum amount is 200. We're reporting the median, not the mean, because there's an outlier. So the median amount of money spent is $50 with a standard deviation of $38.77. Okay, ask me questions if you have them, either by email or post on the Canvas discussion board, ask the instructor section, and let me know if you want to have a live class, want more practice problems. I'm open to helping in any of those ways. All right, hope you guys have a great day. I'll talk to you soon.